Number 1 tells us that Priya is buying raisins and almonds to make trail mix. The almonds cost $5.20 per pound, and the raisins cost $2.75 per pound. Priya spent $11.70 buying almonds and raisins. The relationship between pounds of almonds that they're calling A and pounds of raisins that they're calling R, and the total cost is represented by this equation. So then what we want to do is figure out how many pounds of raisins did Priya buy if she bought the following amounts of almonds. So you've got multiple different ways you can tackle this. So if you wanted to do it like an algebra equation, you could plug it in here and solve, which I'll show in a minute. The other thing you can do is think about the situation as a whole. So thinking about $5.20 times 2 would be how much Priya spent on almonds. So if we multiply those, we get $10.40 that Priya spent on almonds. Then you've got the total that she spent was $11.70. So if we take $11.70 and we subtract $10.40, which is how much she's already spent on almonds, that leaves us $1.30 left for the raisins. So then you could divide by 2.75 to figure out how much raisins she could buy. So then we could take the total amount of money we have left divided by the cost per pound of raisins, and we would get that she bought 0.47 pounds of raisins if she bought 2 pounds of almonds. So that's one way you can think about it. Another way, and I'll do this in the second problem, so you can keep doing it that way. Another way you can do it is just taking this equation, $5.20 times almonds, which in this case is $1 or 1.06 pounds, plus the 2.75 R equals $11.70. So then you can multiply 520 times 1.06, and we get 5.512 for how much she spent on almonds. Then we can subtract 5.512 from both sides, which gets us 2.75 R equals out to 6.188. So that's how much she spent on raisins. So it's a similar idea. It's the same thing as what was here. And then we'll divide by 2.75. And that will get us that she spent, she got 2.25 pounds of raisins when she had 1.06 pounds of almonds. So whichever of those two methods feels like it makes the most sense to you is fine to do for your other ones. I'm going to just multiply this by 5.2. So she spent 3.328 on almonds. I'm going to subtract that from the total cost, which leaves $8 or 8.372 left for the raisins. So then we'll divide by the cost of the raisins, which is $2.75, and that gives us 3.04 pounds of raisins here. And again, either one of those methods is fine. Now in this last one, they put just A, pounds of almonds. So that means that we're actually not going to plug in a number. So we're just going to take the equation as is, and we're going to solve it for R. So if we do this, then we'll just take this minus 520A from both sides, which is basically taking the total minus the almond cost. So then we know that 2.75 times our raisin amount should equal 1170 minus what we spent on the almonds, which is represented by 520A. Then we take whatever money we have left and we divide it by 2.75, and that's going to be the cost of our raisins. So the total minus the almonds divided by the cost per pound of the raisins. Number 2, here's a linear equation in 2 variables. Solve the equation first for x, then for y. So I'm just going to write the equation down here. So 2x plus 4y minus 31 is equal to 123. So in this case, we're going to be solving for x. So we want to leave x on the left-hand side and bring the other stuff over. So when I look here, I see that there's a like term with the 123. So I'm going to bring this over to the other side first. So we're going to add 31 here to both sides because negative 31 plus 31 is 0. So then we'll have 2x plus 4y plus 0 equals 154. Then we want to leave x by itself, so we want to get rid of or move this 4y term to the other side. So in order to get it off of the left side, we're going to have to subtract 4y so that it's 0. And to keep the equation balanced, we do it to both sides. So then we get 2x plus 0 equals 154 minus 4y. Then we want to get x by itself. So we have 2 x's here, or 2 times x. So we're going to divide this into 2 equal parts, and then also divide this side into 2 equal parts. So 2x divided by 2 is 1x. 154 divided by 2 is 77. Negative 4y divided by 2 is negative 2y. So we would end up with this for x. Then we're going to take and do the same thing, but we're going to solve it for y this time. So we have 2x plus 4y minus 31 equals 123. And then we're going to have this same first step. So we're going to add 31 to both sides. So that's going to get us back to 2x plus 4y equals 154. But now this time we want to leave the y on this side. So we're going to want to leave this here. So we want to get rid of the x. So 2x minus 2x is 0. And we'll do that to both sides. So then we end up with 0 plus 4y. So just 4y. And then we get 154 minus 2x. So then we want to get y by itself. So we would divide this into 4 equal parts since we've got 4 y's. So we'll divide each of this into 4 equal parts. So then 4y divided by 4 is just 1y. 154 divided by 4, you could write as a decimal, it's 38.5. Or we could just divide each, the top and bottom, by 2. So we'd get 77 over 2. You could leave it as 154 over 4, or 38.5. Negative 2/4 is negative 1/2. So we just have negative 1x over 2. So again, this is fine doing it as 38.5 minus 0.5x. If you wanted decimals, would be fine as well. Number 3, a chef bought $17.01 worth of ribs and chicken. Ribs cost $1.89 a pound and chicken costs 90 cents per pound. The equation 0.9c and 1.89r equals 17.01 represents the relationship between the quantities in this situation. Show that each of the following equations is equivalent to that equation, then explain when it might be helpful to write the equations in this form. So for this one, I'm just going to take and solve this off to the side for C. So I'm going to write this equation down. So I'm going to subtract 1.89r from both sides. And that got kind of close. Let me restart this. All right, so we're going to subtract 1.89r from both sides. So then you get 0.9c equals 17.01 minus 1.89r. And I'm going to leave the r at the end because that's the way it is in this equation over here. Then we'll divide by 0.9 to everything. And when we divide by 0.9, we get 1c. 17.01 divided by 9 is 18.9. And negative 1.89 divided by 0.9 is negative 2.1r. So then those are equivalent. So we can see that they're equivalent from solving. And then why might it be helpful to have an equation written like that? Would be if you know how much pounds of ribs you're buying and you're trying to figure out how much chicken you're going to be able to buy. So if we know the amount of ribs and we are looking for the amount of chicken. So if you are doing multiple problems where you know how much ribs you're going to want for the situation, then you would maybe want to solve it like this. All right, then the next one gives us another equation to show that it's equivalent, and this time it's solved for r. So we have 0.9c plus 1.89r equals 17.01. So again, this time they're solving for r, so we'll subtract 0.9c from both sides. So we get 1.89r. Now this time they have the c first. So I'm going to write this c term first, this negative 0.9c, and then this is a positive 17.01. Then we'll divide by 1.89. And one other thing to notice here is that they have a fraction. So when we do 1.89 divided by 1.89, that's just 1. Now this they're going to change into a fraction. So what I'm going to do first here is multiply both top and bottom by 100 to get rid of the decimal. So multiplying by 100 moves your decimal place over 2 spaces. So this top number here is going to be negative 90 over 189. So I just multiplied top and bottom by 100, and then we still have the c. And then 17.01 divided by 1.89 is 9. So now when I look at this fraction here, these, to get the top number to be the same, this top number is at 10. So I would divide this by 9 and divide this by 9. And we get that r equals negative 10 over 21, because 189 divided by 9 is 21, and then c plus 9. So then you can see that they're equivalent. You also could just have divided these numbers and gotten the decimal of 0.47, I believe it is. So if you do negative 0.9 divided by 1.89, you get 0.4761. And then you could have done 10 divided by 21 and also seen that it was 0.74761 and notice they're equivalent that way too if you didn't want to do the fractions. So then when would this situation be helpful? So then again, if you know the amount of of chicken you need to purchase, and you're trying to find out how much ribs you can buy. Okay, number 4, a car traveled 180 miles at a constant rate. Complete the table to show the rate at which the car was traveling if it completed the same distance in each of the number of hours. So the rate is miles per hour. So we take the miles driven divided by the hour. And remember, the miles is 180 in each case. And then the hours are changing. So this one is 180 divided by 5, which is 36. This one is 180 divided by 4.5, which is 40. This one is 180 divided by the 3 hours, which is 60. And then 180 divided by 2.25 hours, which is 80. Write an equation that would make it easy to find the rate at which a car is traveling in miles per hour if it traveled for t hours. So traveling in miles per hour, so the rate. So in this one, we're taking, again, the miles divided by the hours. So their rate is going to equal the miles that they traveled, in this case, 180, divided by the time that they traveled. And you can see that happening off to the side here, because as these numbers change, that's that bottom. So then if we had put, so that's the variable, that's the one that's changing. So if we put a t here, then we'd have the 180 divided by t as our general form. Number 5, bananas cost $1.50 each and apples cost $1 each. Select all the combinations of bananas and apples that Elena could buy for exactly $3.50. So we're going to be taking the bananas times 50 and then the apples times $1. So 2 times 50 and then plus 2 times 1 in this case. So 2 times 50 is $1, and then 2 times 1 is $2, and that equals $3, which is not $3.50. 3 bananas times 50 cents is $1.50, and 2 apples times $1 is $2. This one does total $3.50. 1 banana at 50 cents would be 50 cents. 2 apples at $1 would be 2. That's $2.50, not $3.50. 1 banana at 50 cents and 3 apples at $1 each would be $3. That is $3.50. 5 bananas at 50 cents, so 5 times 50 would be $2.50. And then 2 apples each at $1, that totals $4.50. 5 bananas at 50 cents is $2.50, and then 1 apple at $1, that totals $3.50. Number 6, a group of elementary school students and 40 adults are going on a field trip. So 280 elementary students and 40 adults. They're planning to use 2 different types of buses to get to their destination. The first type of bus holds 50 people, and the second type of bus holds 56 people. Andre says that 3 of the first type of bus and 3 of the second type of bus will hold all the students and adults going. Is Andre correct? So we've got 3 of the first type of bus that gives us 50 people on each. So there's going to be room for 150 people on that first type of bus. Plus we're bringing 3 of the second type of bus, which is 56 people on each one. And 3 times 56 is 168. So if we add those together, that's going to give us a total of 318 people that can fit. And then the people that are going are 280 plus 40, which is 320 spots that we need. So is Andre correct that this would hold everybody? And the answer to that would be no. Andre is not correct, because we would only have room for 318 and we need room for 320. Number 7, Elena says the equations A and B are not equivalent. And here's equation A and here's equation B. Write a convincing explanation as to why this is true. So you're going to have a bunch of different ways that you can tackle this problem. So make sure you tackle it based on your understanding. When I look at this, I see this second equation here looks like it's pretty easy to find a solution. So I know that 5 times 7 is 35. So I know that x equals 7 is a solution to this bottom equation. I also know if equations are equivalent, then if a solution works in one, it should work in the other. So when I go up here to plug in, the solution to equation B, it should work in equation A if they're equivalent. So this is 13 minus 35 equals 48. Then that should be true, which is definitely not true because 13 minus 35 is negative 23, and that does not equal 48. So that means that 7 is not a solution to equation A. So my explanation is I know that x equals 7 is a solution to equation B because 5 times 7 equals 35. Then I also know that x equals 7 is not a solution to equation A because 13 minus 5 times 7 does not equal 48. If equations are equivalent, they have the same solutions. So these two equations are not equivalent. Number 8, to grow properly, each tomato plant needs 1.5 square feet of soil, and each broccoli plant needs 2.25 square feet of soil. The graph shows the different combinations of broccoli and tomato plants in 18 square foot plot of soil. Match each point to the statement that describes it. So we can see here on our vertical axis that we're talking about the broccoli. And on our horizontal axis, we're talking about the tomato plant. So number 1 says the soil is fully used when we have 6 tomato plants and 4 broccoli plants. So we have 6 tomato plants and we have 4 broccoli plants. That's going to be here. That's point C. So statement number 1 goes with C. Number 2, only broccoli was planted, but the plot is fully used when all the plants grow properly. So only broccoli. So no tomato, only broccoli, and the whole plot is used. So that's going to be point A because it's on that line and only broccoli plants. Number 3, after 3 tomato plants and 2 broccoli plants were planted. So 3 tomato, 2 broccoli were planted. There's plot remaining. So this means we just haven't planted everything because it's under the line, and that's at point B. So that's number 3, which leaves number 4 to be point D, but let's look anyways. With 4 tomato plants and 6 broccoli plants, the plot is overcrowded, okay, because it's using up too much space for that because it's above the line. So that's point D. Number 9, select all equations that are equivalent to the equation 3x minus 4 equals 5. So the first one has 3x by itself. So if we move this negative 4 by adding 4 to make it 0, and then doing that to both sides, we would get 3x plus 0, which is just 3x, equals 9. So A is true. That one's equivalent. Then if we look at B, we see negative 4 plus 4, which would be 0. And then 5 plus 4, which is 9. So this one would give us 3x on the left-hand side plus 0 equals 9. So that is equivalent. Part C is x minus 4 equals 2. So they just changed the x to the 3x to an x. So they subtracted 3 from both sides, but did it incorrectly because you can't subtract 3 from the x because those aren't like terms. So what they did was this, they minused 3 here and said that this is just going to be x, which is false. So this is not equivalent. D says that x equals 9 is a solution, but we know from right here that 3x equals 9. So if 3x equals 9, x can't equal 9. And then E, negative 4 equals 5 minus 3x. So let's just work with this one and get the 3x alone. So I'm going to subtract 5 from both sides. So negative 4 minus 5 is negative 9. And then 5 minus 5 is 0. So we just have negative 3x, which is really close to this, right? So if I just divide by negative 1, negative 9 divided by negative 1 is positive 9. And negative 3x divided by negative 1 is positive 3x. And we know we can flip over the equal sign. So this is the same thing or equivalent to 3x equals 9. Number 10, Han is solving an equation. He took steps that are acceptable but ended up with equations that are clearly not true. What can Han conclude as a result of these acceptable steps? So he got down to here and he got that 0 equals 1, which is a false statement because 0 does not equal 1. And when that happens, it means that there's no value of x that can make this equation true. For part B, if it was any value of x can make it true, he would have gotten a true statement at the end. He would have gotten 0 equals 0 or 5 equals 5. It would have been a true statement here. And if it was x equals 0, he would have had that. It would have said x over here instead of 0. So C and D are not correct either.